Good afternoon, guys. So now that you have learned everything that you can possibly learn about how to simplify rational expressions, you've learned how to add, subtract, multiply, and divide, we're going to put all of those things together to help you solve equations with rationals in them. And the first one you should actually look at and think, that looks a little familiar, because most of you have heard the words cross multiply, or you may have heard it called the butterfly method before. But if you have an equation and there's only one fraction on each side of the equal sign, all I have to do to solve that equation is to cross multiply. And that's exactly what I'm going to do on number 1. So on the left side here, I'm taking negative 3 and I'm multiplying that by x and by positive 5. So just so I don't forget that, I'm going to put x plus 5 in parentheses. On the right side, I'm taking 2 times x plus 1. So just so I make sure that I don't forget to distribute, I'm going to put x plus 1 in parentheses. Okay? So to solve this equation, my first step is to go ahead and distribute. So I have negative 3 times x, which is negative 3x, and negative 3 times 5, which is negative 15. Then I go to the other side of my equation. I'm taking 2 times everything in parentheses. So 2 times x is 2x. 2 times 1 gives me 2. Okay? And at this point, the next step is to put my like terms together. So I want all my x's together, which means I'm going to subtract this 2x to the other side and get negative 5x. I also have 2 more like terms. I can take this negative 15, move it over to the other side with the 2. So that negative 15, once I move it, will now be positive. So 2 plus 15 equals 17. And your very last step there to get x by itself is to divide by negative 5. So your final answer is x equals negative 17 over 5. And you are done right there. That's your answer. Now, if you got a fraction that could simplify, you would go ahead and simplify it, but there is nothing in common between 17 and 5. Okay? If I look at number 2 is a little bit different simply because it's got more fractions in it. So what I want to do when I have several different fractions going on, I want to try to get rid of fractions. And here's how I do that. I'm kind of going to come over to the side here and I'm going to make a list of every single factor that's listed in the bottom of these fractions. So the first one, there's an x plus 2 in the bottom of these fractions. I'm going to put that in parentheses just so I remember those go together. There's an x in the bottom of this fraction. Okay. When I get to the last fraction, there's a 5 and an x. We've already listed x, so I don't need to list it again. But I haven't listed 5 yet. So I'm going to list 5. Okay? There's my 3 factors that I find in the bottom of these fractions. What I am now going to do is I'm going to multiply each fraction by those 3 things right there. So with your first fraction, I'm going to multiply it by x plus 2, x, and 5. Okay? So let's talk about what that looks like. When I multiply this first fraction by x plus 2, x, and 5, the x plus 2's are going to cancel. All I'm going to have left is an x and a 5 and the 3 that was already on top of that fraction. Okay? And then I'm done with that first fraction. And hopefully you notice it's no longer a fraction. I bring down my minus sign. And now I'm going to go to the next fraction. I'm going to multiply it by the same 3 things. So I'm multiplying it by x plus 2, x, and 5. And here, the x's are going to cancel. So look at what you have left here. You have an x plus 2 left. You have a 5 left that didn't cancel. And you have the 1 that was already on top of the fraction. Okay. My very last fraction, now I'm going to multiply it again by x plus 2, by 5, and by x. So here I get kind of lucky. I have two things that cancel out. The 5 and the x are both going to cancel out. So all I have left is the one that was already on top of that fraction and the x plus 2. Okay? So right there, I've just done what I wanted to do. I got rid of all the fractions. Now all I have left to do is just a bunch of distributing. Okay? So up front, you have 5 times 3, which is 15, and that's with an x. Okay, bring down my minus sign. Right here, you're taking 5 times 1, which is just 5, and then times x plus 2. So 5 times x is 5x. 5 times 2 is 10. Then on the other side, I have 1 times x, which is x, and 1 times 2, which is 2. So one little note that I want to make, the reason that I left parentheses right here is just so that I remember there's a negative in front of this whole little term right here. I want to make sure that I remember that the 5x is negative, but so is the 10. I don't want to forget that. Okay? That's the only reason I put parentheses there, was just so that I wouldn't forget about that negative. And at this point, I'm combining my like terms. So 15x minus 5x is going to give me a 10x. If I keep putting my like terms together, I'm going to move this little x right here. I'm going to subtract it to the other side with the 10x and get 9x. I have 2 more like terms. I can take that negative 10, move it to the right with the 2, so that I get 12. And my very last step here to get x by itself is to divide by 9. And when I do that, I get a fraction that can reduce, and you can type that in your calculator, but 12 over 9 is going to reduce to 4 over 3. And then you're done right there. Okay? So just to recap what we did, if there is more than one fraction in the equation, I'm going to make a list of everything that I find in the bottom of those fractions. Once I write my list, I'm then going to multiply each fraction by the things in that list and see what I can get to cancel out. Because once I cancel things out, I no longer have any fractions that I have to deal with. We all know things tend to be easier when I don't have to deal with fractions. So very last one, let's take a look at number 3. The first thing I notice about number 3 is that this fraction on the left has an x squared in it, which means it can probably be factored. And in fact, it can. So I'm looking on that first fraction for 2 things that multiply to negative 49 and add to 0. Well, that would be 7 and negative 7. So the first thing I'm going to do, I'm not really changing anything about this equation. I'm just going to rewrite x squared minus 49 as its factors, x plus 7 and x minus 7. I haven't changed anything else, so I'm going to rewrite the rest of the equation just like it was. So all I did was rewrite that first fraction. Okay? At this point, I'm going to do exactly what I did on the previous problem. Let me give myself just a little more room here. Okay, I'm going to make a list of everything that I see in the bottom of these fractions. Well, in the first one, I see an x plus 7, and I see an x minus 7. If I go to the second fraction, I have an x plus 7. Well, I already wrote that. I don't need to write it again. If I go to the last fraction, I have an x minus 7, and again, I already wrote that down, so I don't need to write it again. So once I have my list, I'm going to multiply each fraction by these 2 things right here. So I go to the first fraction, and I multiply it by x plus 7 and x minus 7. And that works out really nicely because the x plus 7 and the x minus 7s both cancel. And all I have left in that fraction is just the x that was on top there. So I'll write down the x. I'll bring down my plus sign. Now I go to the second fraction. I'm going to multiply it by x plus 7 and x minus 7. Well, here only one thing cancels out. The x plus 7's cancel out, and I am now left with the 3 that was already on top of the fraction and an x minus 7 that didn't cancel out. Then I go to my very last fraction, and again, I multiply it by x plus 7 and x minus 7. And again, only one thing's cancel out. I can cancel out the x minus 7's, and that leaves me with the 1 that was on top of the fraction and an x plus 7. So again, we've done what we wanted to. We got rid of those fractions. So now, it's just a bunch of distributing and getting x by itself. So I start by taking the 3 times x minus 7, and I get 3x minus 21. On the other side, I have 1 times x and 1 times 7. Hopefully you've noticed there's some like terms here. There's an x and a 3x that I can put together. And at this point, there's a couple different ways you can go. I'm going to choose to put the x's together first. You don't have to do that. So I'm going to take this x right here and subtract it over to be with the 4x so that it's 3x now. I'm going to do basically the same thing with my numbers. I've got a negative 21. I'm going to move that over to the other side with the 7 so it becomes positive. So 7 plus 21 is 28. And your very last step here is to divide by 3, so you get x equals 28 over 3, and that will not reduce. So again, if you're writing this down, your steps for solving rational equations. If there's only 2 fractions, I cross multiply and I'm done. But if there are more than 2 fractions, so like in these last 2 examples we've had 3, here are your steps. Step 1, factor if you can. You may not be able to, and that's okay. But factor if you can. Make a list of everything that's in the bottom of those fractions. Okay? Then take the things in that list and multiply them by every single fraction. See what you can get to cancel out. And after you've done that, you're just solving an equation like you've seen for several years now. Okay? So go ahead, get started on your practice, and let me know if you have any questions.